Hello, I welcome you all to this another interesting screencast, and the problem reads a vertical force P equal to 10 pounds is applied to the ends of a 2 feet cord AB and a spring AC. If the spring has an stretched length of 2 feet, determine the angle theta for equilibrium. Take the spring constant as 15 pounds per feet. From the same figure, the second problem reads determine the unstretched length of the spring AC if the force P is equal to 80 pounds, causes the angle theta equal to 60 degrees for equilibrium cord. AB is 2 feet long, and take the spring stiffness as 50 pounds per feet. Both these problems are coming from the Engineering Mechanics Statics textbook, the 13th edition by R.C. Hibbeler. So we have this system here, and in the first case we have been asked to determine the angle theta. So we are assuming chord AB is unstretchable. By this I mean the length of AB does not change before and after the application of the load. Okay, so cable, let me write down this. Cable AB the length of cable AB does not change before and after the application of the load, so it remains the same, and therefore length AB is equal to 2 feet. All right, you can see it also, right? Okay, so the length of this cable remains 2 feet. All right, so this is 2 feet. Okay, so this is a LAB equal to 2 feet, and then we'll call this, we're going to call this as the length L final. I mean not L final, call it LAC. No, L final, right? Since this is the only one here, I'll call it just L final. Okay, LAC, which will be equal to L final. Alright, then when you look at this particular problem, there are a lot of things that we don't have. We don't have the tension force in cable AB, we don't have the spring force AC, we also don't have the angle theta, and we don't have another angle for the spring force. We need another angle, this angle here, okay, which we're going to call phi. We need this angle, okay, which is similar to this angle here, right? We need that angle there, right, for us to work out the components. So we need an angle there, and this angle is phi, like so. All right, so there we go. Let's write down the components. So we are going to have, we do the sectioning. We section this cable there, let's section the spring there, then we'll have some components in these particular cables. We'll have one component like so. Okay. We'll have another component like so. We'll have another component like so. We're going to have another component like so. Okay. There we go. There we go. There we go. There we go. Right. And let's call these components. So we'll call this one is spring force AC, just AC. This one we'll call it a just tension AB. Okay. We'll have another component like so, and another one there like so. Then we'll have another component in this direction like so, and another one like so. Okay. So let's call this as our AC cos phi, and this one as our AC sin phi, and we call this one as AB cos theta, right? Because this one here is theta, this here is theta, right? And then we call this one as AB sin theta. Okay. There is need. So again, it's like knowns are more. We have phi, theta, AB, and AC. So the more the knowns, the more the equations, right? So right now we need a minimum of 4 equations. So let's reduce this so that we are able to solve this. Okay. So we have theta, we have phi, we have AB, we have AC. All right. Let's work out this. A little bit of sine functions. Maybe let's see how we can manipulate theta and phi so that we can work out this using the sine and the cosine function. Okay. Let's work out LF first, the length LF using the cosine function. So LF, okay, so we are using this particular triangle here, okay, this one, okay. I didn't want to draw another one. LF is just going to be equal to, remember the cosine rule. This is what we are applying here. Is equal to LF is just equal to this length AB, so 2 squared plus BC 4 squared, remember, minus 2 by AB by BC, which is a 4, and then cos theta. Remember this, and then everything you squared. Remember cosine rule? Therefore, L final is just going to be equal to, you can simplify that, have 2 squared plus 4 squared. That's a 20. So we'll have a 20 here. Then the other side there we have a 2 by 2 by 4. That's a 16. So we can say this is equal to a 20 minus 16 cos theta. We can simplify this further if you want to, or we can leave it the way it is. Okay. So this is our L final, right? All right, expressed in terms of theta. All right, we need this because AC, it's a spring force. A spring force will have, spring force, right, is equal to Ks according to Hooke's law, where Ks is the change in the stretch, which is just L final minus L original. All right. Okay. What else? What about this phi? Let's write this again using another. This side, let's say we use let's say sine. So we say sine phi divided by BA or AB, which is a 2, is equal to sine theta divided by L final. All right. So this is another one. So this one we can even write it as sine phi, because we need a sine here. You've seen there's a sine phi here, right? This is equal to 2 sine theta divided by L final. All right, so writing this, it becomes sine phi is just going to be equal to 2 sine theta divided by L final is just this. Okay, you see, you can replace this, you can bring this, Okay, this is what we are doing. All right, so this just becomes a 20 minus 16 cos theta. So we can rewrite L final, we can simplify it further. This can be equal to, we can factor out 20, this is a 4 by, we can factor out 4, there we have 5 minus 4 cos theta, right? And this becomes a 2, right? 5 4 cos theta, right? So this is equal to 2 root of 5 minus 4 cos theta. And therefore, if we are to replace this here, the 2 cancels out, so we'll have a 2 sine theta divided by 2 root of 5 minus 4 cos theta, which is just equal to sine theta divided by root of 5 minus cos theta. Great. So there we go. So we found sine phi. We also need a cos phi. So from the same we can find we can set up another equation using cosine rule. Okay, so we can say a 2 squared, okay, 2 squared, that is the BA, the length of BA. Okay, 2 squared is going to be equal to L final squared plus BC, which is 4 squared minus 2 by 4 by L final cos phi, right? I think this. So we can make cos phi subject to the formula. So this becomes cos phi is just going to be equal to of course it goes the other side, so we'll have we're going to have L squared plus 16, this is So this 16 minus 4 is a 12. Okay, so this is going to be plus 12. All right, then divided by 8. 8 L final, right? Is that so? 8 L final. So we can later on divide this. So this becomes equal to L final, like so. So we can then say, what is our L final? Our L final, this just becomes a 4 times 5, that is squared, 4 cos theta, okay, plus 12 divided by 8, 8, that is 8 by 2, which is a 16 root of 5 minus 4 cos theta. So the top part can later on again, we can simplify the top. We have a 4 there. We have a 4. That's a 20. So this becomes a 32. There is a 12. 32 minus 16 cos theta divided by 16 root of 5 minus 4 cos theta, which later on becomes just equal to, what is 16? That is a 2. So this becomes just a 2 minus cos theta divided by root of 5 minus 4 cos theta, right? Okay, so there we go. We have cos phi. So we have cos phi, which is this one here, and then we have sin phi. Okay, so this is important because if you've seen, we have cos phi for AC and sin phi for AC. There are these components. So one more thing that I think we need to work on is just finding AC. AC is the spring force, so this is just equal to a K, the spring constant, times S. Okay, if I write it somewhere here, this one. So this is the spring force. AC is the spring force, which is just K times S. Okay, and then we know that K is just equal to what's K? Okay, we'll leave it like this one. We'll come and plug in values later on. We know that S is just equal to L final minus L original. Okay, I think this we can fit them here, right? I think so there, so that we reserve on space. So I think with this information, what we need to do now is to go to the first case, which is case 3-2. Okay, 3-2. So now we are going to apply the equations of equilibrium. So we'll say summation of forces in the x equal to 0 in this direction being our reference. What do we have? We have AC cos phi minus AB cos theta equal to 0. Okay, then we have summation of forces in the y equal to 0 going up being our reference. What do we have? We have AB sine phi plus let me start with AC. I just want them to be the same order. Doesn't matter which one you start with. AC sine phi plus AB sine theta minus p. Okay, but we know here that p is equal to what is p here? Is equal to 10 pounds. Okay, and also k here is equal to 15 pounds per feet. All right, so this is just going to be minus 10. We'll write it in advance, equal to 0. Okay, so we have these two equations. How many unknowns do we have? Of course, we have theta, we have phi, we have AC, we have AB. All right, so we need at least a minimum of 4 equations. We've already found some, which is great. So let's simplify this before we move on. So we have AC, all right? We have AC, we have summation of forces in the X, and so we have how many equations? We have all the equations, right? So now let me write this. We can write this as AB sine theta is equal to a 10 minus AC sine phi. Then we divide this by the corresponding equation AB cos theta, and this divided by AC cos phi. So this becomes a tan theta equal to 10 minus AC sine phi divided by AC cos phi. So now we've generated one equation that gets rid of AB, which is great. So now what we have in this particular equation now is sine phi and sine theta, which we already have, which we just need to rewrite so that we just have now, and also replace AC. So we know what AC is. AC, we said, is just equal to, where is it? AC is here, it's just equal to K. AC, that's K times S. And we know what K is. Okay, simplified. So I'll say, I'll bring this, I'll multiply this, it comes this side. So this becomes AC cos phi tan theta minus equal to 10 minus AC sine phi. All right, so seeing this equation now, we're just writing it like that. So now let's simplify this. So this AC we said is just K, which is a 15 by S, which is just 2 root of 5 minus 4 cos theta, okay, minus the unstretched length of the spring, which is L0, is equal to 2 feet, right? So this is going to be equal to minus 2, and then we close this. This is AC, okay? This is AC. Then cos phi, we said cos phi. Where is cos phi? Cos phi is here. It's just a 2. It's a 2. It's a 2 minus cos theta divided by root of 5 minus 4 cos theta, okay? And then we have tan theta, okay? Then 10 will bring it the other side so that we just make one equation. Then we say minus 10, then plus AC. AC is the same 15. We have 2 root of 5 minus 4 cos theta minus 2 Okay, minus 2, then we close this. Then sine phi, which is just equal to sine theta divided by root of 5 minus 4 cos theta equal to 0. Alright, 0. I think this is better. So it has reduced a little bit. Okay, it has reduced a little bit. So we can now solve this. And the technique that we are going to use is trial and error. We are going to use trial and error. Okay, trial and error. Okay, and our interval for theta is just theta from 0 to 90. These are very vital. Okay, and basically what we are doing is we are saying we are on the number line like this. Okay, we have negative values, positive values, and we are saying our function of theta, there's going to be a value of theta which will give us a negative. There's going to be another value of theta that is going to give us a positive, and somewhere in between, that's where the solution lies, or that's where the solution is, somewhere in between. So we need to keep on iterating. Okay, so we can write this as a function of theta, which is just equal to 30 times 1 minus 1 divided by root of 5 minus 4 cos theta. Then we close this, then we open this, then we say 2 minus uh, 2 minus cos theta tan theta plus sine theta minus 10 equal to 0. I mean, we'll just leave it like that. Alright, so now we have the interval. We have theta is from the interval. Can I just write the other side? So we have theta from is in the interval 0 degrees to 90 degrees. Great. So let's draw up our table. Let's keep on going down. Then we start doing the iteration. All right, so we have theta, and then we have the function of theta. So we keep on iterating to see where this is going to get closer to 0. So when theta is equal to 0, what happens? We have to plug in this. So I need another calculator for averages. Okay, let me use this for averages. Then I'll need to plug this formula, if possible, once and for all in my calculator. Let me do that. So 1 divided by root of 5 minus 4 cos theta. Let me write this for decimal places to 0.00. Okay. I close bracket. I close another one. Okay. I close this, and then I close this. Right. Then times 2 minus cos again 0.00. I write it in advance, and then times tan 0.00, and then plus sine 0.00, Okay, minus 10. All right. I think this is about it. 2 cos this, and then times tan, times tan. All right. I need to put another, sorry. Oh, come on. Sorry. So 13. All right. So we've entered our formula in our calculator once, so that we'll just be using another calculator for taking the average. So when theta is equal to 0, we just expect a minus 10. Okay. Let's go to when theta is equal to 30. Let's enter 30 in our equation that I just entered once on my calculator. Where are we? There. So it's 330. Where else? Another 30. How many places? 1, 2, 3, 4, 4. And another 30. And another 30. Alright. What do we get? We get a minus 3.31. Okay, let's go to 45. Let's enter this. 45 degrees. What do we get? So we enter 45. That's the first one. Then 45. That's the second one. Then 45. That's the third one. 45. Okay. So this gives us a positive 9.28. So we know in between here, that's where the solution lies, right? In between here, that's where the solution lies. So we're going to iterate the two. I mean, we'll get the average of the two. We'll get the average of the two. So let's do so. What is the average of 30 plus 45? Don't want to disturb my equation on my calculator. I want to use another calculator for the average is 30 plus 45 divided by 2. So this is a 37.5. So let's feed in this. We'll see what we get. A 37.5. Great. Let's feed it in. 37.5. We go to the next one. 37.5. We go to the next one. 37.5. We go to the next one. 37.5. All right. So we have a 1.97. So now again, we always focus on the minimum value for the positive and the negative. Those are the ones that we use for averaging. So the minimum here will be 30 and this one, right? So we get the average of the two. The average of the two. So we have a 37.5 plus a 30 divided by 2. So we have a 33.75. So let's plug in that. A 33.75, 33.75. Okay, 33.75. Okay, another one, a 33.75. Okay, and finally a 33.75. Okay, so we have a minus 0.89. So we get the average of the two now. These are the have minimum values. Okay, So 37.75 plus, 33.75 plus 37.5 divided by 2. So we'll get a 35.63. So let's plug this in. A 35.63. Okay, we go to the next one. A 35.63. A 35.63. A 35.63. All right. So this gives us a 0.48. So again, we'll get the average of this. The error is too big. So 35.63 plus 33.75 divided by 2. So we have a 34.69. So we keep on doing this process until the error becomes small. Yeah, you can use a computer to do this, but it's important to know what is going behind the scenes. Okay, 34.69, because computers are designed by humans. So 34.69, 34.69, and finally 34.69. All right, so what do we have? We have a negative 0.22. The error is too big. I need at least 2 to 3 decimal places there before the numbers begin to appear. Okay, so let's get that again. Average of that, those are the smaller than 34.69 plus 35.63. This divided by 2. We have a 35.16. Let's plug this in. I know this can be tedious, but this is one of the methods when we are using hand calculations. Okay, 35.16, 35.16, 35.16, 35.16. All right, so we have a 0.13. All right, so again, let's get another average there. The error seems to delay in converging. 35.16 plus 34.69 divided by 2. Let's say we have a 34.93. Okay, let's plug this one in. 34.93, 34.93, 34.93, and then we have 34.93. Okay, 0.042. This at least is not bad, but the error can reduce further. Let's get the average of that. We have a 34.93 plus 35.16. This divided by 2. So we have a 35.05. Let's plug in that. We see 35.05. Okay, 35.05, 35.05, 35.05. Okay, so this is there like so. 047. Oh, this one is really taking too long to converge, right? Let me draw another table there. All right, so we have theta there. We have f of theta. Okay, so we can take another average of the two. So that is 34.93 plus 35. We know the solution is just between 34 and 35. 0.05 divided by 2. So 34.99. Maybe this will give us something better. 34.99, 34.99, 34.99, 34.99. Okay, so we have 34.99. This is the third one. This, okay, let's see what we have. All right, this one seems better. 0.00224. That's 1, 2, 3. Okay, this is better. This is better. So we are going to go with this one. So we'll say approximately theta therefore is approximately equal to 34.99 degrees. Case 2 dash, 3 dash 23, 3 dash 23. Okay, and what are we being asked here? Here we've been told our value of P is equal to 80. So we have P equal to 80 pounds. What else? We have K equal to 50. K, the spring stiffness, equal to 50. This is 50 pounds per feet. And then we have theta here. Theta is given equal to 60 degrees. Okay. And we are being asked to find the unstretched length of AC. So we are being asked to find L original for AC. Okay. All right. So we already have the equation. Okay, we know AC is equal to KS. So we can just write this and then find what this length is. Okay. Great. So we know that AC is equal to K times S. Okay. And this therefore is just equal to K is 50. Okay. And then we have L final, which we just calculated. What is our L final? Our L final is just 2 root of 5 minus 4 cos theta, then minus L original that we are looking for. All right. So this is the equation for our L final. So this is okay. And then we have this equation now, the total equation. So we have summation of forces in the X and in the Y. So we just need to use those particular equations and then feed them back, and then be able to solve for this unknown. All right. So we need AC, and once we have AC, we can later on sort out this particular problem. All right. So we are going to let's use this equation here. Let's use this equation, this one that we just developed. Okay, it's in this equation. So we can use this. Let me just copy it. I bring it down like this, and then let me come down, bring it somewhere here. Great. Hello. Right. But this equation that we just put, if you remember, this is P. This was P in the first case. So we need to change this and replace this with our new P. Okay. Our new P is equal to, what's our new P? Our new P is equal to 80 pounds. Okay. So with this equation, we need to find what sine phi is. And sine phi is just equal to sine theta, remember in the first case, divided by root of 5 minus 4 cos theta. And we know what theta is. So let's check it up. So this is the equation here, right? This one here, right? We have sine phi. We have also cos phi. Okay, we need these equations. So let's quickly find what this value is. If we were to plug in, we know what theta is. This theta here is theta is equal to 60, and so is this one, theta is equal to 60. So if we plugged in those values there, we'll find that we have a 5 minus 4 cos 60, okay, root of 3, and then sine 60 divided by answer. That gives us a 0.5. And then we have a cos theta, cos phi. We have a cos phi, which is just also equal to 2 cos theta. It's 2 minus cos theta divided by root of 5 minus 4 cos theta. And we know what theta is. So at the denominator is root 3. So minus cos 60, 2 minus cos 60 divided by root of 3. So this gives us a 0.8660. So with this, we can therefore write this equation here. We'll say AC, we know what AC is, but let's find it first. So we can say tan theta cos phi AC plus AC sine phi minus 80 equal to 0. All right. So if we are to replace the values there, then we'll have a 0.8660 tan theta, which is just tan 60. Okay. We have tan 60 AC plus 0.5 AC minus 80 equal to 0. And therefore, our AC is just going to be equal to 0.8660 tan 60 plus 0.5. Then we have 80 divided by that. Then AC here becomes equal to 40 pounds. Since we have AC, we'll use this equation here, you see. So say, we'll say AC, AC divided by 15 is just going to be equal to 2 root of 5 minus 4 cos theta minus this. And therefore, this unstretched length, we already know what this is. The unstretched length is just going to be equal to, so we have 2 root of 5, 2 root of 3, okay, and then a 40 minus 40 divided by 50. Therefore, this gives us a 2.66 feet. Okay, so I think this is about it. So we found the unstretched length of the spring. This is the unstretched length of the spring, and then we've also found the approximate value of theta for case number 1 or case 322. All right, so we have these two solutions, L node 2.66 and theta equal to 34.99. Right, so I hope the video was helpful. Let me write the solutions maybe somewhere here so that they are visible. So I think it's fine. I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye. See you in my next screen.